Uh-oh, he's recording now.
Now we're recording. All right. So let's talk about the 1.6 section first. Okay, 37 through 45. So, and I have some very specific ones that I want to go through. Okay, and hopefully leave you some work time, and then we can, if you've got some other ones that we didn't get covered, you can ask me about those then. And I've got some review problems that you could be working on here. So on 37 through 45, this is just kind of basic, fundamental chart information, right, that we need to be pretty good at for the quiz tomorrow. So 37, this is f prime. So where is f increasing? It would be from -3 to 4. And we don't care about where it hits 0, that's fine. It's still increasing. The f is still increasing all the time. So from -3 to 4. Don't include the endpoints. F is decreasing then from -4 to -3. F has stationary points where it crosses the x-axis. Write that answer this way. X equals -3 and 3. Or you can write x equals -3, x equals 3. Do not put that as an ordered pair. Why would this be wrong? What's that? Well, that's what I mean. Why putting the point 30? Why saying that the stationary point? I understand where you see 30 because it's this. Why is that a wrong answer to that question?
Saying that all x is between 3 and 0.
Well, yeah, that's kind of an interval. But I mean, even if I accept that that's a point, why is that not the point? Whoa. That's right. The question is, where on the f graph is there a stationary point? That point is on the f prime graph. We don't know where the local max, or excuse me, we don't know where the stationary point is on the f graph. We know it's when x is 3, but we don't know the y value. So it would be incorrect to say that that point is the stationary point. So only give the x coordinate when it asks for where is a local max or min, where is an inflection point, where is a stationary point. Give just the x coordinate. All right. Where does it have local max points? Well, that'd be anywhere this graph does what? Positive to negative. It never does. So there are no local max points. Local min would be when it goes from negative to positive, which would be at x equals -3. Local min at x equals -3. Is f concave up at 2? Well, that'd be where f prime is increasing, right? In the chart, concave up of f is when f prime is increasing. So that'd be from -4 to 1, and from -1. -4 to -1, and from 3 to 4. All right? Oh, I'm sorry. It didn't want to know when it's concave up. I read that wrong. Is f concave up at 2? No, because it's decreasing, because f prime is decreasing, right? It's concave up when f prime is increasing, which is those other places. At 2, it is not increasing, so it is not concave up. Where does f have points of inflection? According to the chart, maybe we should pull up the chart here real quick. According to the chart, the points of inflection are when we change concavity of f, which is when f prime has to go up to down or down to up, which means local max or min, right? So, where's that at? -1 and x equals 3. X equals -1 and x equals 3. Local max, local min. And we don't care about the bounce here. That doesn't have anything to do with the inflection point. The fact that this is a local max and this is a local min is what makes those inflection points. 44, this is that equation of the tangent line thing we talked about. So all you need is a point and a slope. They give you the point, -3 and 2. All you need is a slope, which means you need f prime of -3. Well, that would be this y value right here. And that is 0. So if you want to simplify it, you sure could, and that would give you that. Number 45, the equation of the tangent line, we need the point and the slope. They give us the point 1,3. So we put that point in there. All we need is a slope. So we need f prime at 1. F prime at 1 is 2. So that is the slope, and you can just stop right there. So you need, I mean, that is a big part. It's probably not half the points in the quiz, but the ideas of the chart, I mean, I suppose the ideas of the chart are so woven into almost everything that it probably is half, maybe more, of these interconnections of writing a tangent line where inflection points, local max, local min, was it increasing, decreasing. Hopefully that's good if that's a big part of it, because that is such an important concept that we need to have that down. Okay? And so those hopefully are easy. Now, a little warning, I'm not trying to scare you, but a little warning. If on the quiz you have a section like that, and you get off track in your thinking, you could miss a bunch in a row. So don't be scared of that to the point you overthink it, right? But you just got to know, okay, what graph am I looking at? And then look at your chart, right? Hopefully you memorize and can draw yourself a chart when you get the quiz, and just answer, okay? But you got to know, is that an F graph? Is that an F prime graph? Is that an F double prime graph? And just be careful about it, all right? And make sure you're on the right path with those. And I'll try to help you with that. When we pass it out, I'll say, no, okay, read directions. This is an F chart graph, and this is an F prime graph, and so forth. Try to help you with that. All right, let's go to the next section. I've got a couple here that I want to talk about. Let's start with number 32. All right, 32 says you're supposed to sketch an F graph that has these properties. All right, so what does F greater than 0 mean? Positive. What's F positive mean? Above the x-axis. So I need a graph that's above the x-axis. What's F prime positive mean? Slope is positive, which means what for F? Always going up. What's F double prime positive mean? F has to be concave up. So I need a graph that's above the x-axis the whole time, is always going up, and is always concave up. E to the x would fit with that, right? It would be above the x-axis, it would always be concave up, and it would always be increasing. Then on 33, they changed it to F prime negative, which means it always has to be going down. So, above the x-axis, concave up, and always going down. It would be something like that. Okay. That was 32 and 33. Let's do 43. Okay, let's take a look at 43. Now this would be one where I would give you the calculator. You would get to use a calculator if I gave you an equation like this so you could see what its graph looked like. Or, more likely, it would be on the no calculator part. The quiz is going to have a small calculator part, and I'm going to tell you later about what's going to be on it. So more likely, this would be on the no calculator part, and I would just give you the graph. Okay, so let's just assume you had the graph to start with. Now, a couple of things, though, that are important for the future of why you should know pretty much what this graph looks like, even without a calculator. First of all, if you FOIL this all out, it's going to be an x cubed. So an x cubed graph has this basic shape. Okay? Another thing that you should know is when it's in its factored form, these numbers here are the roots. So -1 and 2, we know are going to be the roots. And another interesting point about cubics is when you have a double root like this or a squared term in there, that is a bounce. Where it's going to just bounce off the x-axis. So just with that information, I already knew this. Now, the only thing I didn't know is where this would be a minimum. But when you put it on your calculator, it turns out it's right at 1. Okay? So here is our F double prime graph. So now they're going to ask me some questions. So here we go. A says, where is F concave up? Well, on the chart, F's concave up when this is positive. To infinity. B, where is F prime decreasing? F prime is decreasing when F double prime is negative. This is negative all the time until 2, except for that one little spot where it hit 0, but we don't care about that. So negative infinity to 2. F prime decreasing, of course, is when F's concave down, so it makes sense. That would be the other section of that. Where does F prime have stationary points? Now we got to think about the chart. F prime has stationary points when F double prime is 0. Oh, okay, so that would be here and here. X equals -1 and at 2. Stationary points of F prime. Where does F have inflection points? F has inflection points, possible inflection points, remember, when F double prime is 0. But the main place it has inflection points is if F's concavity changes. Well, F's concavity changes when F double prime changes from positive to negative, because that's when F goes concave up to concave down. Right? If I was going to make my chart there, when F double prime changes positive to negative, F changes concavity, and that only happens where? At 2. So x equals 2 is an inflection point. Now, I might ask why on the quiz. Explain that. Just explain what the chart says. So you'd say x equals 2 is inflection point of F because it changes concavity there. Why does it change concavity? Because F double prime changes from negative to positive. So F changes from concave down to concave up.
So why doesn't it change?
Right here, because F double prime is negative and stays negative, so therefore F is concave down and stays concave down. So there's no change in concavity, so there's no inflection. Okay, x equals 2. All right, sketch a graph of F prime. That's the part you're mostly interested in, so let's do that. So let's graph F prime, and let's talk about what we look for here. F double prime is what when it comes to F prime? The slopes. So these y values are the slopes of what I'm about to draw. So what are you thinking to yourself as you start over here? It's negative. The y values are negative. And where do you start? Wherever you want. We don't know where to start. They didn't tell us. Now sometimes they'll tell you. Sometimes they'll say F prime of 1 is this or whatever. They'll give you a starting point. They didn't here. So my graph has to start doing what in the beginning? Got to go down, right? Since this graph's negative, the graph I'm going to draw has to go down. So since it's going down, I'll probably start up here somewhere. But it doesn't matter. I could have started somewhere. So I'm going to start going down. Now I'm going to go down to where? -1. Now I'm still going to keep going down actually, but it's going to go down until 1. I think you want to draw these things until you get to each of these kind of important points: the maxes, the mins, the roots. So it's going to go down, but it's going to be leveling off because I know right here the slope is 0. The y value is 0. But then it's negative again and getting more negative. So this graph's going to go down, and I don't know where to. I mean, right to there, let's say. Whatever. Now, again, yours could be vertically shifted. Yours might not have crossed it. It doesn't matter. Any graph you have with the same shape, as long as it's vertically shifted, you'd be okay. All right, now where? It's still going down, right? These y values are still negative, so the slope is still negative. This graph's still going down, but it's leveling off. It's leveling off because the slopes are getting less negative. Right here I have a 0 slope, so it's got to flatten there. And then positive and getting more positive, so it's got to go up. Now that fits with everything we answered in A, B, C, and D. We knew we had a local min right here. No, that's, yeah, we talked about stationary points, I guess. We knew we had 2 stationary points on F prime. We had a flat spot there, and we had a local min there. Okay, this graph was decreasing all the way, we said, until 2. In part B, we said F prime is decreasing all the way till 2. Sure enough, it is. Okay, so there you go. Something in that basic shape. Yes? Yeah, I think that's exactly right. I think I'd put big old dots there, and then that these match up with those. Right? When I grade it, yeah, I'm like, what's it look like? Well, no, I'm going to say, okay, does this change it? Because basically you have this flat spot. Does that coincide with this? And does this inflection point here coincide with that? And does this minimum coincide with that? Yes, that's the key. Finding those points, right? Okay? All right. And 44 is very similar. 44 is probably easier just from the standpoint that it doesn't do much. I mean, e to the negative x, if you graph it, is just this, right? Well, if you're going to graph the f prime of that, what are you noticing about this? The slopes are, I mean, these y's are always positive. So the graph I'm going to draw is going to be what? Always going up, right? And these points are getting less positive, so my graph's going to be going up, but leveling off, right? And so the graph that I would draw, and it doesn't have to cross right here, that's just coincidence. You can have any vertical shift of that, but I mean, that's it. I mean, these are positive y values, so the f prime graph's always going up, and since that graph's getting less positive, my slopes have to be getting less positive. So it's got to be leveling off, okay, or something like that. Okay, let's go to 21. 21 is a really, really good problem. 21 is a type of problem that we will continue to get better at doing. 21 is a kind of problem where you have to take multiple pieces of information and things you know and put them together. You know everything you need to do 21, but putting it all together is the hard part. So let's walk through what you're thinking should be here. They tell you g prime of 1 is negative 4, and they ask you this. So let's take what they're asking us and investigate that. Is g decreasing at 3? What are they really asking me there? Look at the chart now. Is the slope, meaning g prime, negative? So what they're really asking me is g prime of 3 negative? That's what they're asking. If I can figure that out, then I can answer the question, right? If g prime of 3 is negative, then yes, this will be decreasing. Okay? If g prime of 3 is positive, then it's increasing. So they told me a point on g prime. So the best way to tell if g prime is negative, I think, is look at a graph. So they told me g prime of 1, and they told me it was negative 4. So I'm way down here. What I need to know is if the g prime graph at 3 is down here or if it's up here, right? That's what I need to know. If it's down here, then I will know it's negative and I will know this is decreasing. So what is this question really? What is this question using? This is a speed limit law. This is a speed limit law. Because what I need to know is I start here, and I need to know that if I go over 2, how far up do I go? Do I only go up this far? Or do I go up this far? And that's what the speed limit law is. The speed limit law says if you start here and you know how fast you're going, or you know what the slope is, then you'll know how far up you go. Now, do we know the slope? Remember, this is g prime. Well, we need to know something about its slope, which is g double prime. Do we know anything in this problem about g double prime? Mm-hmm. Yes, why? Because we have the graph, right? We have the graph of g double prime. So this is a little different speed limit law than we've done before, but it's still a speed limit law. Okay? So, look at the g double prime graph. What do you see between 1 and 3? Yeah, but I'm not sure that matters. We're looking at its y values, aren't we? It only goes up to about 1/2, a little more. So worst case scenario, let's say the slope is 1. It never is 1, even, right? The slope is never even 1. G double prime is never even a y value of 1. Now, it's always positive, right? It's always positive, so we do know this graph's going to go up. Okay, that didn't help much, because I want to know how much it goes up. Well, that's where the y value comes in. It never is as much as 1. So that means if I go over 2, how much am I going to go up? Not even 2, right? I mean, at the worst, 2, but not even 2, right? Because the slope is never even 1. So if I go over 2, I couldn't even go up 2. And if I only go up 2, where am I at? Down here. I'm still below. So there you go. So g prime of 3 has to be negative So G has to be decreasing. So to do that, to answer that fully and really get full credit, you would have to probably a picture and quite a bit of words. You'd probably have to say, with that picture, you'd have to say, okay, G prime of 1 starts at -4. According to the G double prime graph, G double prime never exceeds 1 or is always around 0.6 or whatever, which means that if I go over 2 from 1 to 3, I can't even go up 2, which is going to leave G prime of 3 down around -2 or so. Since G prime of 3 is going to be negative, G will be decreasing. So you had to put a lot together. You had to put together the notation of what it was. You had to, and then all of a sudden think that it was speed limit law and how that showed you that G decreasing. But think about it, every single one of those things we know. I mean, we have access to all that pieces of information, but we had to put it together to answer that question. All right, 22. So you can kind of see what I was talking about when I said 37 through 45 is kind of your basic run-of-the-mill chart kinds of questions. There's going to be plenty of that on the quiz. But, you know, then there may be, think of last quiz, there was a question or two that went beyond kind of some of that, where you really had to kind of put stuff together. Well, same thing here. You know, there could be a question or two where you really got to put stuff together, but you really want to be good at that, at the other stuff. All right, so this is a little more run-of-the-mill speed limit law. Okay, this one, they tell me that f prime of 2 is -1, so I know that point. They're going to ask me about f prime of 3, so that's over here. Okay, so that's going to be going over 1. They tell me this. What's this tell me? Slope is between 0.1 and 0.5. So that means if I go over 1, I could go up 0.1, I could go up 0.5, but we're somewhere in between. So they want an upper and lower bound of f prime of 3. Now, yeah, they give me some other stuff. They say f prime, f double prime are continuous. That just means they're nice and smooth. Nothing weird happens. They tell me that x is between 2 and 4. That just means for all this information, it's true in between 2 and 4, which is where I'm working right now. So most of that stuff doesn't really matter. But they want an upper and lower bound on f prime of 3. So if we go over 1, I might go up 0.1, or I might go up as much as 0.5. Well, where would that put me? -0.9, -0.5. So my upper and lower bound, the lower bound would be -0.9, and the upper bound would be -0.5. So that's just more of just kind of a normal speed limit law. Rise over 1. All right. Yes. Yes. If these would have been inclusive, then these would have been inclusive. Exactly.
You have to write it
You could put -0.9, -0.5. Now, actually, it should have been this, probably, right? You could have done that. That would have been fine. Yep. That could have been fine. All right. I think. Wow. Zipped right along there. Let me look if I. Oh, okay. Let's go back to 18, 19, 20 here real quick. I don't have a picture of that to put up here, but well, here we can. Let's put it right here. I think everybody's been here today, so I doubt anybody's watching the video. But this won't be okay. So on 19. Or on 18, does G have a point of inflection? G. Now this is G double prime. So does G have a point of inflection at 3? Yes? Because positive to negative, G would be concave up to concave down. Point of inflection. 19, rank those in order. I think they are in order. Aren't they? The way they are? I think they're in order the way they are. Now, why is that? Because G double prime all the way till 3 is what? Positive. Except for this one place where it's 0, it flattens. But G double prime is positive all the way. So G prime's got to be what? Increasing. If G double prime is positive, G prime's got to be increasing. So if the graph's always increasing, G prime of 0 is going to be littler than G prime of 1, going to be littler than G prime of 2, going to be littler than G prime of 3. So they got to be going up. So that it's simple as that. Okay? 20. Is g prime of pi greater than g prime of 3.5? Well, pi and 3.5 are past 3, so it's the opposite reason. Here, since g double prime is negative, means g prime's got to be going down. So g prime of pi would be here, and g prime of 3.5 would be below it. The graph's decreasing because pi is before 3.5. So g prime of pi would have to be greater than g prime of 3.5 because the graph's going down. So it's the same really question as 19, just asked a little different, but it's the same justification. All right, and then we already did 21 and 22. Okay? Any others? Because I want to do 26 yet. Talk about that. But anything else besides 26? I think we've hit a lot of them probably. And I want to give you some work time, and it looks like we're going to have some of that. All right, so let's talk about 26 and 27. So go ahead and get your calculators out. Everybody get logged in. I'm not seeing everybody logged in. Has somebody not got their calculator today? Or maybe it kicked you out? Brenna, you're not logged in. Ryan, Hayden, you're not logged in.
It's not letting me.
Okay. Try again. There's Brenna. Brenna's in. It keeps giving you an error. You have the right network? Or, Hayden, what's yours saying? Okay. All right. I'm going to send you a quick poll. As soon as you guys get logged in, it should come up. Here's when I send this to you. Here's what you're going to type in. Identify the graphs of f, f prime, and f double prime, respectively. So, in other words, if you think B is the f graph, and you think C is the f prime graph, and you think A is the f double prime graph, okay, then put them in that order. So BCA would be f, f prime, f double prime. Okay, so put them in the way you have. All right, we will start that, and I will turn that off. All right, 23 of you are in now. Hayden, you got in. Ryan, still no luck?
Is this 25 or 26?
This is 26. This is 26. And remember to submit it, you use the trackpad and the arrow up to where it says quick poll, and then you click and then pull down and it says submit answer. So you put, depending on which one you think is F, F prime, F double prime, in that order, just type in, it's like BCA.
Feel my incorrectness.
Yes, Neil.
It just like won't connect to the network.
Yeah, that could be your batteries.
Try turning it off and then back on.
Yes.
Yeah, I know, I did. I typed in what I got, but I had
Huh.
I did AC. I know it's wrong. I know I'm wrong.
I'm just saying.
Okay, wait, I'm trying to figure out 27.
Okay.
27. Even our, I
Understand.
know, but we're gonna do that one too.
Go get a different tab.
That's what I was.
Yeah. All right. Well, there's always one person who doesn't follow directions and puts commas in there, but that's okay. Robbie. All right. So,
Wow, Rob.
all right. So the most common answer was CBA. Now, there were a few people in here this afternoon or this noon that might have had BAC and have since switched theirs to CBA. In the other class, the majority had BAC. Okay? So let's see who's right. And all right. This thing here's what we've talked about on this, and some of us this new. That the thought process should be, and I really like these problems. Because it makes you look at the chart in again a different way. But the thought process, I think, should be focusing first on these roots. Because that's where the stuff happens, right? I mean, when F prime is 0, that's when F has max and mins and flat spots. When F double prime is 0, that's when F prime has max, mins, and flat spots. And when F double prime is 0 is when F has possible inflection point. So at 0 is where all the important stuff happens. So what I would do is look at this right away. I would notice that this and this, because there's so much information there, you got to focus in on the bits and pieces. Well, what's that tell you right there? Positive to negative. What's one thing that could tell you? Local max. So if this was F prime and this was F, because that would correspond to that local max, and that seems to make perfect sense. So positive, this is going up. Negative, this one's going down. So that seems to make perfect sense. So you could go with that. But the thing you'd have to remember is not only do F and F prime have a certain relationship, but F prime and F. So it's possible that this could be F prime and F double prime. So how do you tell? Well, if this is going to be F and F prime, then this would have to be F double prime. So now look at what the chart tells you about F double prime. What I notice here is that this graph's always negative. If this is F double prime and it's always negative, what's that tell you about F? Concave down all the time. I mean, that's what F double prime tells you, is concavity of F. So if F double prime is negative the whole time, F's got to be concave down the whole time. And I look at this, and I don't think it is. Here towards the end, this switches. And not only that, but if this is F prime, if you look at the chart, when F prime is decreasing, F should be concave down. Looks like it is. But it stops decreasing right through here. So if this dotted one is F prime, when it starts going up, its slopes are positive. So F double prime, or its slopes, F double prime needs to be positive right through here. So it can't be that. So it can't be BAC. So that means this has to be F prime and F double prime. Now, it had a lot of good stuff, but it failed on that last part. So this has to be F prime and F double prime, which makes this F. Now let's just double check that real quick. If that is true, we know this connection's good because of that local max thing we were already doing. But if this is F double prime, it's positive for a while, meaning this one would have to be concave up till about there, and it looks like it is. Then this graph dotted one goes negative, F double prime goes negative, making this one go concave down, and that seems to fit. Okay, so the F prime, or the FF double prime connection seems to fit, and then of course we can look at the FF prime. This one is positive all the time, this one's increasing, and right here at 0 it goes positive to negative, so we'd have a local max right there, and we do. So that seems to be it. So it's got to be C, B, A for that. All right, let's give you another chance. 27. Send you another poll. So look at 27, and we'll do the same thing. We'll answer it the same way. Okay, identify, put it in order. F prime, F double prime. Ryan, did that work? Ever work? So it could, yeah, it might just be the battery. I've had that happen before where people just couldn't see nothing, and the next day it was. I think I've got some review exercises for you that you can work on. Has got some of these in it as well, so, or one of them anyway. All right. Another minute here, real. Get these submitted. A lot of you have it. All right. All right. Now, it turns as I'm looking at the answers, everybody has some good stuff happening there because, and may not be completely right, but everybody's identified A and C, I think, as having a kind of the FF prime connection. Now, whether it's FF prime or F prime, F double prime, that's the key because, again, focus in on the 0, and right away, right here, you see this dotted one going from negative to positive, which should mean what? Local min. So right there, the C graph could be the F prime, and the A graph could be the F. In that case, you would have ACB. But then you need to look at that a little closer. If that's true, then this would have to be F double prime, right? If this is F double prime, it's negative all through here, right? If F double prime is negative, what's F? Concave down. So we look at the F graph, is it concave down? No. So that eliminates it already. Now, sometimes it might be correct for a little while and then all of a sudden fall apart. So if that can't be, then it can't be ACB. So that means FF prime has to actually be F prime, F double prime, leaving that one for F. Okay, so let's take a look at that. Let's look at the FF double prime connection here. So if this one is F double prime, the C graph, negative, negative, negative till there, the F graph's got to be concave down till there, and it kind of looks like it is. For a little while, it looks like it's concave down. Then it changes positive, looks like this one goes concave up till about there. Then it goes negative, concave down, looks like till there. Then positive, concave up, okay? That looks good. And so that seems to fit there, and of course F prime, F double prime we think fits because we were already looking at that. This would be a local max. This right here would be the local min. This right here would be the local max. So it looks like the F and F prime relationship holds there. Okay? So, what would that be? BAC. BAC. And a lot of people have it. So, all right. So I'm going to give you some work time here, and I'm going to give you some review problems. First, I'll put up a little bit of a kind of a review summary, maybe you might call it. This isn't. These are just some things I jotted down real quick. So I guess you could jot this down. I just tried to jot down a couple of talking points here off the top of my head. So I don't know how much this helps to write, but that's up to you. I mean, everything just kind of blended in through these sections. I mean, 1.4 is where we first learned about a derivative and the derivative notation and rates and slopes and all that stuff. And then 1.5 we kind of talked about zooming in, and we talked about calculating some slopes. And then 1.6 we came in and did all the chart stuff and all the interrelationships, and that's the biggest part of this. And then 1.7 was really more of the chart stuff. It just brought in the second derivative and tied that all up. So, I mean, 1.6, 1.7 is probably the majority of the stuff. So the things we've been working on today and maybe yesterday, I mean, that's a big part of it. So maybe just to highlight a few things from early in the section, being able to do on your calculator where I give you an equation and ask you to estimate the slope at, say, 3 by zooming. Well, what's that mean? That means pick 2 points really close together. So just on your calculator, you trace it 3 and 3.001 or something. But write that out when you do that. Write out what you're doing. And then just estimate a slope doing that. So don't overthink that. It's just doing a slope calculation. So whenever it says by zooming, that's what we mean. And I'm not going to ask you to zoom in, give me a window. We did that on some of the exercises. I don't, right? So you don't even have to literally zoom in. Just by picking 2 points really close together, you're zooming in, right? So if it says by zooming, if you just do that you've zoomed in, okay? Now the other calculator thing that I will have you do would be, there was a homework problem number 54 on page 46 about height of a ball if it's dropped or thrown. Now, I don't think we spent a lot of time going over that. So, if you want to go back and look at that problem here when you have some work time today and ask me about it or ask each other, whatever. But basically, I'll give you an equation that will be in this format. And you just need to understand that that number is the initial height. The middle term is the initial velocity. That number in front is the initial velocity. So I think on that particular problem, on number 54, it said something like this. It was like 74 plus 38t minus 16t squared, I think was the equation. So what's the 38 there? The initial velocity. And I think one of the questions was the ball thrown up or down? Initially. Up. How can you tell? Because 38 is positive. If the 38 was negative, it was thrown down. The 74 is the initial height that it was thrown from or dropped from. Okay? And then the velocity equation would be this. So for that particular one, the velocity equation would be 38 minus 32t. Right? And then since you have the calculator, I might say estimate the velocity at time 2 by zooming. Well, the velocity at time 2 by zooming would be h of 2.0001 minus h of 2, right, over 0.0001, that kind of thing. I mean, right? I mean, we could get the velocity at 2 by just putting it into the velocity equation. But I might say estimate the velocity by zooming. Well, you put it into the height equation, right? Because that's a derivative of velocity is a derivative of height. So you'd be doing the slope of the height equation. The slope of the height equation would be the velocity. So but those, So it's going to be a very small calculator part tomorrow. And the way it'll work is I'll hand that part out first, you'll do that part, and then hand that in, put your calculator away, and then do the no, then get out, then they'll hand you the no calculator part. Now, you will have the option if you do the, most of the quiz is no calculator. So if you're spending a lot of time in the calculator part, I may say, hey, you might want to put that aside and go to the no calculator. So I will let you put it under your desk, put your calculator away, get the no calculator part out, finish that, hand it in, and then go back to the calculator part if you want to. That's kind of how they do the AP test. Okay, so that's how we'll do that. So very small calculator part. That's about all you'll have to do with it. Okay, so the no calculator part, of course, all this chart stuff that we've been doing, all that stuff, and I'm going to give you some problems to work on here in a minute. And then what else have we done? We've done some sketching of a graph and estimate the slope with rise over run, draw a tangent line. Remember when we did this with Bismarck? We had this thing here, and I gave you the whole description of east of Bismarck and all that stuff, starting at noon, that kind of thing. And you were supposed to explain that in words. What was that? You remember? At 2 hours, which meant at 2 p.m., since we started at noon, it's moving east 70 miles per hour, because P was the position, so P prime would be the velocity, right? And that'd be miles per hour. So it was moving east, since it's positive, at 70 miles per hour at 2 p.m. So something like that, where you have to kind of put that into words, okay? And then, of course, the speed limit law, and we did some review of that today as well. All right? Okay, so last thing then would be on your assignment sheet down at the bottom. There are some review exercises there. There's a bunch of them, and most of them are pretty good. But I have found a few that you probably would not need to do. I would say you can skip number 9. You probably just cross it off. And these are of lesser importance. 2 through 6, 11, 53, 99. You might just put a question mark by those or something. I mean, those are ones, if you got some time and want to do them, they'd be decent problems to do, but they're probably of lesser importance regarding the quiz. And 25 would be one that you would get to use a calculator on if there was one like that. The rest of them are probably no calculator. So if you want to practice that velocity, height stuff with the calculator, you probably got to go back to number 54 on page 46. Okay? So that leaves you a fair amount of problems. Now, is it a complete review of everything? It's pretty good. I mean, this chapter does have a pretty good review. Most chapters don't, to be honest with you. But there's a lot of chart stuff, good chart stuff in there. There's some interpreting sentences. There's some looking at graphs. But you might want to go back through your own homework, too. All right, you got the rest of the time to work.